Good morning. Today we'll be talking about another important non-parametric test which is Wilcoxon sign rank test. Again, we use the non-parametric methods when our data is ordinal and if the normality condition for scale data is not met. Wilcoxon sign rank test is used when we have two dependent samples and it is equivalent to the parametric test per t-test. What to test for the normality? In case of the per t-test, we use the normality of the pair differences. So the Wilcoxon sign rank test again is another popular non-parametric test for matched or paired data or data from two dependent groups. This test determines whether there is a statistically significant difference in the median of a dependent variable between two related groups. It is equivalent to the pair t-test, as the Wilcoxon sign rank test does not assume normality of the differences of the two related groups. It can be used when this assumption has been violated. Let's take an example of ordinal data. Here we have a study on new varieties of vegetables. Asked consumers to rate two factors. The first factor is the home-grown factor and the price factor, F1 and F2, for level of importance in making choice on a 5-point scale, 1 to 5, starting from 1 as not very important to 5 level, which is very important. So we are talking here about ordinal data. The question: is there evidence that consumers views factors differently in terms of importance or choice? Here is the data. Now we go immediately to the Minitab test. Okay, here is our data. Let's enlarge this. Okay, we have the two choices, F1 and F2. Now we want to test the difference between the two choices. We want to calculator. We want to calculate the difference. Between F1 minus F2. Here is our data that we want to test if there is a significant difference or not using the non-parametric Wilcoxon sign rank test. Statistics, non-parametrics. Here you are, one sample Wilcoxon, because we are working with a difference as a sample. The variable is the difference. We can test the median, that the two medians are not equal. Okay. Here is the test now, the hypothesis that there is no difference between the two medians, or the difference is 0 versus non-equality of the two medians. The statistics indicated a high p-value, more than 0.5, so therefore there is no significant difference between the two groups. Now let's take another example of scale data. Here we are. So another example. Here is Here's the data on new diet for reducing weight or losing weight for people that were subjected for a certain period of time. And here we have the weight before and after. This data we want to check first of all if the data is a scale measurement. We want to test if the distribution of the differences is normal or not normal. Therefore, the first step is to calculate the differences the same way we did before. Okay, here we had to define between before minus after. Let's go now. So we have, here's our data that we want to work with. Okay, these are the data, right? Now we want to test the normality, statistics, basic statistics, normality test, differences, use this one or the same thing. Okay. Now here is the outcome of the result. This is the normal line, and we notice that the data are deviated from the normal line, which means, and the p-value is 0.018, which is less than 0.5. It means that there is a significant difference, or the distribution is not normal, because in testing normality, the null hypothesis states that the distribution is normal. Since we rejected the null hypothesis, so the distribution of the differences between the two groups is not normal. Therefore, we have to go for non-parametric test. Okay, since these are two dependent groups, the same people, the same subjects, exposed to the treatment, and we have the weight before and after. So we'll go now for the testing the hypothesis, statistics. We go non-parametrics, sample Wilcoxon. Okay. Again, our variable is the differences. Test median. Okay. Here are our results. Again, the null hypothesis, the alternative hypothesis, and the p-value indicated a significant difference between the two groups, since the p-value is less than 0.05, 0.014. Thank you.